Right, let's look at this theorem. It says a line drawn from the center of a circle perpendicular to a chord. So we have a line that is drawn from the center of a circle and perpendicular to the chord. Then what does this line do? It bisects the chord. So the theorem says a line drawn from the center of a circle perpendicular to a chord bisects the chord, meaning that it divides this chord into two equal parts, meaning that the distance from there up to there is the same as the distance from there up to there. Let me name this as A, and then this one is M, then this one is B. So it means that AM is equal to MP. So a line drawn from the center of a circle perpendicular to a chord bisects the chord. Let's prove this theorem. But what do we use to prove this theorem? You have to know that. You have to know the constructions you have to do and the theorems you have to use. Given a circle with center O, with chord AB, you can see chord AB, where OM is perpendicular to AB. We have the line OM from the center and perpendicular to chord AB. We want to prove that this line divides AB into two equal parts. So we want to prove that AM is equal to MP. Right? We have to remember the constructions we have to do. The first thing to do when you're proving theorems is to construct. So you have to remember those constructions. The other thing, you have to remember the theorems that you use to prove another theorem. Like here, we have to use congruency. So we have to construct OA and OB. So we've created two triangles here, triangle OMA and triangle OMB. And then we have to use congruency to prove that AM is equal to MB. If triangle OMA is congruent to triangle OMB, then it means that MA is equal to MB. So we need to prove that these two triangles are congruent. Remember the conditions for congruency. We have side, side, side. And then we have side, angle, side. And then we have angle, side, angle. This one also can have angle, angle, side. You can also have side, angle, angle, right? And then the last one will be right angle, hypotenuse, side. Now let's prove our triangles. We have our triangle OMA and triangle OMB. Let's highlight them. We have our two triangles OMA and triangle OMB. So we want to prove that these two triangles are congruent, right? So let's start with OA and OB. So we have OA, which is equal to OB, and then what's the reason? Radii. You know that radius is just the same. So OA and OB are radii, so they are equal. And then we have for triangle OMA, we have OM. And then for triangle OMB, we have also OM. So this is a common side. So meaning that OM is equal to OM. It's a common side. And then the last one, we have our angle M1 and angle M2. We're given because it says that a line drawn from the center of the circle perpendicular to a chord. So it means angle M1 and angle M2 are 90 degrees. So we have angle M1 is equal to angle M2, and both are equal to 90 degrees. We're given. So now we can then say triangle OMA is congruent to triangle OMB. So we've managed to prove that these two triangles are congruent. And then why are they congruent? Because of right angle, hypotenuse, side. Therefore, from this, we can conclude and say AM is equal to MB. AM is equal to MB. Then what is the reason? We can say congruency, or just write that triangle OMA is congruent to triangle OMB. Okay, or write the word congruency is still fine. This is how we prove that AM is equal to MB, or we prove that a line drawn from the center of a circle perpendicular to a chord bisects the chord. And then the acceptable reason for this theorem, we say a line from center perpendicular to chord.